So to read the problem number 7, a 3 kg block sits on a 30-degree incline with kinetic friction coefficient of 0.10. It is connected by a light string over a frictionless pulley to a 2 kg hanging mass. Assuming the system moves, find the magnitude and direction of the acceleration and the tension. They're asking for the same set of variables or parameters that they had asked in the previous problems. It's just that this is an inclined plane, right? So let's try to draw the pictorial diagram first and then the free body, and then move on to the equations. So just to say, this is the surface, this is 30-degree, we can call it theta, and then we have the block M1. So M1 is 3 kg, M2 is 2 kg, and the coefficient of friction, whatever it is, it's 0.10, right? And then it says this is the rope. We have a pulley here. This block is tied to the rope, and then we have M2 hanging. So let's talk about the forces that are on this block M2. It is M2G. As always, let's consider this direction clockwise as positive. So when it comes down, we'll consider M2G as positive, and the force on this opposite is tension force T. And since again this is a single rope and it's a frictionless pulley, this will also have the tension in this upward direction, and then in this direction it has the Fk, the friction. Now this lying on this, it also has the normal force, right? It has the normal force. Normal force is always perpendicular to the surface. So this being an inclined surface, it is perpendicular. So we'll call it N or Fn. And then we have Fg, or force of gravity. It's nothing but M1G, right? So now, like we had discussed in the previous one, since this is a vertical one, we have to break it into the components which are perpendicular to this surface and parallel to this surface. So if it is perpendicular, then we draw a dotted line, it moves down, and then it will be opposite to the normal force. Normal force is the thrust which is pushing this block upwards, and the force of gravity is always acting downwards. Since these are the components of force of gravity, they also act in the downward direction, like this way and this. So like how we discussed in the previous video, this theta will match this, so this will be also 30 degrees. So this will be our Fg. So if I want to refer back my previous one, so this one here is Fg sine theta, and this one is Fg cos theta, right? Just hopefully like it's visible to you. So this is Fg sine theta and Fg cos theta, right? The components when we break this force. So now what all we have on M1, let's see. So we will always use F is equal to ma, this as our base formula. So if you consider the force that are all the forces that are parallel to the inclined plane, we have, since we said the clockwise direction is positive, we will consider t as positive in this direction, minus fk, and then we also have fg sine theta in the same direction, fg sine theta, which is equal to m1a. So fk, let's calculate fk here. So before going to fk, I was also thinking like we should consider this, the normal force, and it is opposite to this one, fg cos theta, right? So n is equal to fg cos theta. So when I say fg, it's nothing but n is equal to m1g in this case cos 30 degree, which is 3 times 9.8 times cos 30 degrees. So if you use your calculator, you will have, I think it will be about 25.46 newtons. This is the normal force. So you might have understood, right? The normal force is equal and opposite to this component fg cos theta that we have derived, that's acting on this block m1. So but one more thing is, here we have to consider the friction. So now we have this, so now we can calculate fk, the friction force. I'm just doing it on the side. So it's 25.46 times 0.1, which is approximately 2.55 Newton, right? So I was actually a little confused, and I checked on the internet, like why is the friction applied for this fg cos theta and not for fg sine theta. So this is what it says. Friction depends on how hard the surfaces are pressed together, not on how steep the hill is, assuming this is a hill. So that pressing together force is the normal force, right? So this is the normal force that's pressing this block to the inclined plane. So the pressing together force is the normal force, the force that pushes up on the object. On the incline, the normal force is smaller than the weight because only part of the gravity pushes into the surface. So we have n is equal to m1j cos theta. The kinetic force is proportional to the normal force, and that's why we have Fk is equal to n times mu k, which is 25.46 times 0.1, right? So Fg cos theta is the one which presses towards the inclined plane, and it works with the friction, right? Like it's pressing down, it means it will press hard and make sure the friction is acting along with that. Whereas Fg sine theta, it will make it slide down. So it works against the friction. So it's not really, so you can't really multiply the friction coefficient with Fg sine theta, but you will have to multiply with Fg cos theta, which is 25.46 times 0.1, you get Fk. So the next one, this is for block 1, right? And then for block 2, what are the forces we have? We have m2g, again this is positive, minus t is equal to m2a, which we are again using F is equal to ma, m2g minus t, because tension is acting in the opposite direction, is equal to m2a. Now it should be mostly plugging in the numbers and trying to get the answer. So we have two things on M1 block M1, right? So this one and this one. So if you start plugging in here, T minus Fk, we already have 2.55 minus Fg is nothing but M1g sine 30, which is equal to M1a. I mean M1 is 3 kg, so T minus 2.55 minus 3 times 9.8 times, I'll just write parenthesis sine 30, so I close, and 3 times a, 3a. So we have T minus 2.55. Let me do my math. So this M1g sine theta, which is this one, comes to about 14.7 newtons, is equal to 3a. So this is 17.25 is equal to 3a. So this will be now 2 times 9.8 minus t is equal to 2a, right? So we have 19.6, right, minus t is equal to 2a. Now just substituting. So let's move t to the other side, and we have 19.6 minus 2a, right? So now if you substitute this into t here, we have 19.6 minus 2a minus 17.25 is equal to 3a. So if we calculate a, so we have 2.35 is equal to 5a, right, after balancing. So a will be equal to 0.471 meter per second square. This is a, and based on this we can use any of the equations and calculate t. If you want to use this equation, then t is 3a plus 17.25, which is 3 times 0.71 plus 17.25, which is, so we have 18.66 newtons. You can just verify this as the same if you will get it. So t is equal to 19.6 minus 2 times 471 should give you the same answer. So 18.66 newtons, right? That's the tension. So then they're asking the direction. Since we got a positive direction, so that means this is the clockwise direction, right? So if you see now, like I said, so M2 moves down. So whatever we assumed is right, because we got the positive answer, and then they are asking for the movement, right, the direction. So you can say, depending on the multiple choice question, if it's a multiple choice question, then you can say M1 is moving up, and they may have options like M2 is moving down, with the pulley moving in the clockwise direction, something like that, right? So I think I hope this is clear. Let's work on other problems tomorrow.